All righty, you write down the formulas. (8.2). So I think 8.2 is more chill because you don't have to worry about solving for multiple triangles. It's just going to be one, and that's it. Because case 3 and case 4 that I wrote down last time is basically guaranteeing one triangle. So this is the formula to find the sides. So sides, number 1. So I'll solve these earlier, make it a little neater and easier to use. So C is equal to a squared. Let me maximize this for you. Plus b squared minus 2ab cosine c. I'm going to bring some aluminum foil. A squared plus c squared minus 2ac cosine b. Now, in order to find one of these sides, you kind of need the other two sides. You see this? Right, to find b, you need to have a and c and angle b. So if you're missing two sides, you probably can't use law of cosine. So that would probably be case 1 and 2. I keep referring to all these angles. Let me write down what they are. This is A. This is B. This is C. Opposite sides are little c, little b, little a. All right. Angles. So in order to use the angle formulas, you need to have all three sides. So capital A is equal to, I went ahead and solved for the angle for you. That way you don't have to do too much algebra. Just plug it in. B squared plus C squared minus A squared over 2BC capital B Okay, so those are the three you're going to need for the angles. Let me double check them. Yeah, looks legit. Okay, so I'm going to do the example on the next page because I don't want to smash it in here in the middle. Here at the bottom.
Wait.
What's up, man?
I didn't need to see the page. I didn't.
Yeah, I'm not turning it. I'm gonna wait a bit.
All right, cool.
Let me know when you're done. Or
I got you.
yeah, you're gonna need these. You guys good on this page?
No, not yet. Let me see the triangle piece real quick.
Top part?
Yeah.
Gotcha. All right. So A, B, 106. It's 2 and 4. Okay. So that's angle C. I think that's what the homework set it up. It's a little different from the formula, but it doesn't really matter. So we have angles. Let me go ahead and write down all the information, I guess. We don't have A. We don't have B. We don't have C. Little a is 2. Little b is 4. Little c is right there. Oh yeah, we had C. Okay, so solve the triangle. We need all the pieces. So since you have 2 sides, that guarantees one triangle. It also guarantees case 3 because I have 2 sides with no opposite angle, right? Notice how I don't have an A or B. And then I have an angle C, but no opposite side. So when that happens, you cannot use law of sines. It's not possible. So you got to do law of cosines. All right, so let's find, if we use the formula to find C, you could technically shift back to law of sines if you wanted to. So C is equal to, solve for C first. So that's going to be something. Okay. So a squared b squared minus 2ab cosine 106. So I would just punch this into your calculator. Let me go grab one. Two squared plus 4 squared minus 2 times 2 times 4 cosine 106. Double check that I'm in degrees, and I am not. So I'm going to redo that calculation. There we go. So C is 4.94. Let's just round 2 decimal places, I guess. So now I have all 3 sides. You could do law of sines at this point to find capital A and B, or B. Or you can just use law of cosines again. So since we're using a new technique, let's go ahead and use law of cosines. So capital B will be equal to cosine inverse of a squared plus c squared minus b squared over 2ac. That'd be cosine inverse of a bunch of garbage. 2 squared plus 4.94 squared minus 4 squared over 2 times 4.94. So you hit the cosine inverse button. You have a graphing calculator. I think the regular TI-36 Pro can also do the fraction button. So it's all good. 2 squared plus 4.94 squared minus 4 squared over 2 times 4.94. So 51 point, I don't know, let's round to 2 decimals, 12. 51.12 degrees. 51.12 degrees. So now that you have 2 angles, the last one is the easiest one, right? How do we find A? So just subtract these two from 180 and we'll be good. Hey, 106. Okay, so that's it. Got all the angles and all the sides. Okay. Any questions on finding that side and 2 angles? All right, let me box the ones we found so I know later, and so do you. Okay, let's see. 20 degrees. So the one we did was similar to this guy. Number 4 though has nothing but sides. Let's do that one. That one is case 4. You guys cool on this page? Good. Example 2, let me write down they had. We'll just draw the triangle out. This time I'll write the way we have in the notes. ABC. C is 26. A is 14. B is 16. Okay. So this is case 4, meaning you have to use the law of cosines to find the angles. A is equal to cosine inverse There we go. So there's A. So we're gonna have to do this twice because once we have two angles, we can just subtract from 180 and find the last one. So we'll work less. So cosine inverse. Plug all that garbage in there. 16 squared plus 26 squared minus, I can't read my own handwriting. Those are 14, right? $14. So plug that into your calculator. I don't know what that is. That's in degrees. We got 27 point. Let's see what these told us around to. I don't remember. Looks like they did 2 decimal places. Okay. So 27.80. But pretty straightforward, right? Once you have the sides, you can just keep using the formulas. It's not that bad. Capital B. I believe it's this one, cosine inverse. Goes A squared plus C squared minus B squared over 2AC. So what is that going to be? Plug all this in. Oh, wait a bit. All right. What you guys get for cosine?
Which segment?
This is
Just wanted to verify.
8.2,
8.2.
I believe.
Thought it was just in that one. It always confuses me because it never shows the numbers on here.
Well, on my
I
end,
feel like it's hard to find.
yeah,
And then, of course,
I
it
forget
then-
too, man.
Huh?
I forget too.
Yeah,
I
sorry.
do.
And then it always has it like random. So.
Alrighty. I believe that's what they got, right? For A and B. Let's see. A is 27.8, B is 32.2. And the last one, of course, will just be subtract from 180. Excuse me. All right. Subtract the 27.8. That's it. 120. So capital A, put it all in one place. Capital B. And C, capital C. This is what we found just now. The rest was given to us. Any questions on applying the formulas? Hoping it doesn't, it's not too bad.
No, with the formulas, it definitely makes sense.
So the only trick is you need to identify when to use which one, right? So I guess you should always try to use law of sine. If you notice can't, then just try cosine. Okay. Or if another rule of thumb would be if you have nothing but sides, you have to do cosine. Law of cosine. And whenever you're forced into law of cosine, then you should also understand that there's only going to be one triangle. You don't have to check for 1, 2, or none, like we did on 8.1. All right, so let's move on to the area formula. You guys cool on this page? I'll wait a bit. So according to my pre-calc professor, he said this formula is called Hero's formula, spelled Heron. I never checked if it was BSing me or not. Seemed legit.
Is it still 8.2?
Yeah. The Hero's formula. So all you need is all the sides and you can do it. So the area is equal to square root S times S minus A times S minus B times S minus C. S is equal to 1/2 times A plus B plus C. So add the sides up, divide by 2, and then plug the S there. And here and there. So this is a formula I like to use. There's a few other area formulas that the homework might refer to, but I like this better. Just find the sides and you're good. Okay. But you can do whatever the hell you want. As long as it's legit math, I don't care. Find the area. So then this is going to be the first, the next example, I should say. Example 3, 4, yeah, 3. Find the area for the triangle in example 2. What were the sides for example 2?
$14, $16, $26.
Okay. So since we have all the sides, we can find S. So what is 1/2 times the sum of all these sides? What is that? 56, right? Times divided by 2. Too tired. Check. Yeah, 56 divided by 2, 28. Okay. All right, so just plug that in and we're good. A is equal to the square root of 28 times 28 minus 14 times 28 minus 16 times 28 minus 26. So it looks like it's about 28 minus 16, that's 12, right? Yeah. 20 minus 14, that's 14. 28 minus 26, that's 2. It looks good to me. Here's some extra area formulas in case you need them. I don't use them, but just in case. Number 1, in the book they call the area K, and it says equal to 1/2 times A times B times sine C. Number two, the other formula. So let's say you don't have all the sides, you can use these instead, but I don't really see the point. But it's cool. I think that's all. That's the main points of this section. I think we should practice a little bit. But first, let me check schedule. So we did law of cosines. Guess you should do vectors in a plane. Now, we actually don't have much left. Isn't that crazy? Nice. All right. Yeah, let's look at vectors real quick. We got till technically we got about, I've got an hour left still. Okay. So vectors in the plane. And when I say plane, I mean a two-dimensional space. Okay, not an airplane. Like the sheet of paper would be some plane. Okay. Now, a vector can be used to measure forces, such as like gravity or friction. And these forces or these vectors have magnitude and direction. So they're different from just lines or rays. Like they actually mean something. So whenever you see a vector, it could potentially tell you how much force you got and what direction it's going. Like so when you get to physics, you're gonna be dealing with vectors a ton, drawing diagrams, and all this stuff in this section will make more sense and you'll be applying it. So for example, if you're pushing a block like to the right, you'd have a force pushing it to the right, and you'd have a certain length of the vector, which is magnitude. So let me just try to give you a general explanation here. So the vector v, which we denoted with a little hat here, has an initial point P and a terminal point Q. Find the position vector. This would be your example, I guess. It's best that we just do an example so you can see it. Find the position vector in the form AI plus BJ. Another notation would be using these little brackets, A comma B. Okay. So in pre-cal, it starts off very generic, what a vector is. So they'll give you, the homework will start off like this. They'll give you a point P and say, all right, we're at this location 1, 3. Q is at 5, 2. And they want you to find the, it's an ugly 5. Find a vector that goes through these points. Now, what you do is pretty simple. Vector V that goes through these points will basically be 5 minus 1, comma 2 minus 3. So you do the, if we call this x1, y1, x2, y2, this will be my x2, this will be my x1, this will be y2, y1. Okay. It's always going to be the final point minus the initial point. So the vector will look like this: 4, negative 1. Okay. Which is the same as 4i minus 1j. So either notation is fine. The book, the homework and book is going to use both. So know that these are the same. So if they have the triangle brackets, this is the I and the J. And if we were in 3-dimensional space, you'd have a K, but we're not going to go there. Well, maybe, I forget. We're not going to do much applied stuff, but we might discuss it. It becomes important and when you try to cross two vectors. Like for example, if you had a current going in a circle, the circle would be in 2-dimensional space, but the magnetic field would be coming out out here this way. So if the current is going on and around, the field would be perpendicular to the 2-dimensional current. So when you get to physics or higher level physics and engineering, you'll have forces in 3-dimensional spaces. Or if you had like, I don't know, if you had a beam and a structure, you'll have forces going in 3-dimensional directions. But anyway, visually, what the heck is this? It's very simple yet very complicated, so it's really weird to discuss. So the vector 4, -1 would be 1, 2, 3, 4 right here. So the vector will look like this. It's basically an arrow. Okay. So if this represented a force, it'd be a force going in this direction. And then the amount of force would be the length of that vector. Okay. Length is the amount of force. And then of course you can calculate the direction using sine and cosine. It'll be like some angle down here in the quadrant 4, which we're gonna do later. That's what I want you to understand what it is, right? It's just some arrow going to some direction with some amount of magnitude. Magnitude is just the length of the vector in generic terms. Okay, because math is very generic, very general. When you apply it to something, it becomes specific. So I'm trying to give an example of physics applications. Okay, it doesn't have to be physics, but for the most part, that's where you're going to see it a lot. And then engineering uses a lot of ideas from math and physics to solve problems or build things. They'll be using all this stuff. But anyway, that is a vector that goes through these 2 points. There. That's all we did. Super basic, but it means a ton. You see what I'm saying? Right. The work itself was no big deal. But what it means is a big deal. All right, so in this homework, they'll start out by just find the vector, and then they'll tell you, all right, find the magnitude of V. So V is equal to -5i plus 12j. So I'm going to switch back and forth with notation so you can get used to it. So the formula for magnitude and the symbol is this. It's like a little double absolute value. The book might use a bold V. Depends. So 2 lines means magnitude. The formula is the square root of A should I call it A1? Yeah, I guess that's right. A1 squared plus B1 squared, where V is equal to A1 comma B1. So that's your formula for magnitude. So if you want to know the amount of force on an object, you would calculate its magnitude. Okay. So A and B are right there, right? So the work itself is no big deal. That would simply be -5 squared plus 12 squared. This would be 25 plus 144, which is 169, right? So any questions on how to find the vector given 2 points, and how to find its magnitude given a vector?
where does the one come from? When you're multiplying by one? Like the formula for that is actually the formula is a times 1 squared plus b.
Oh, that's just the name I call them, A1 and B1. It's not the number one. So it's a sub, it should be a subscript. It looks like it's not, right? Should be. Though. There's something on my eraser. Whatever. Leave it as AB if you want. Any other questions on example 2? Okay. So far not too bad, right? I hope. Okay, so let's look at problem 18. As you can see, the first few questions, they give you a visual vector graph, and they ask you to just simply write it using that notation with the little brackets. 37. So this is the 0.37. This is the vector 37. So there's a big difference. Magnitude, you would use the formula we just did earlier. So the first question will be pretty chill. Same thing for 12. Same 13 is similar to example 1. We just did that. This one I think we need to do on here because I'm not going to be able to graph or draw this. So let's see here. Okay, this is what we're going to do. Okay, so they give us a vector v and a vector u. They say use the figure to sketch the graph of negative v. So negative v would be the exact same vector but going in the negative direction. That's the wrong picture. Let me use the other one. So this would be negative v, the blue one. That makes sense. So negative, whenever you have a negative on a vector, it just switches to the other direction. Complete opposite. So negative u would be over here, right? Obviously. So they're gonna have you choose multiple choice. It's not A, it's not B. It's gonna be C. Do you see why it is C? Right. Okay. Now, 2 times B. The 2 is considered to be a scalar. That's what the book calls it, because it scales the vector by that factor. So times 2 would be doubling the size, doubling your magnitude. Okay. So if V is right here, then 2 times V would be like about that long, right? Maybe a little less. Okay. There's my double V. So obviously it's not that one or this one. gonna be that guy, right? Looks like, yeah, check that out, it's almost exactly the same size. Anyway, so that's what a scalar does. So it would scale visually the size, but also the numbers. So for example, if I were to, let's say V was this guy right here, right? Times 2 would just double the -8 and the 6. So like 2V would equal -16, comma 12 with those little bracket things. That's not a Z, I swear. Okay, so that's all the scalar does. You can also multiply by -2, so it'll be double in the opposite direction. Okay. Alrighty. You can also do something called algebra of vectors. So you can add them together. And they do this thing called a parallelogram rule. Okay. So what they do is they do, so let's look at the answer so we can kind of understand here. They have V and U. So they do, if you were to add them together, so from tip to that tip there, the hypotenuse basically of your parallelogram, a lot of L's in it, will be this, okay? So basically all you would do from adding positive, right? The middle vector would be U plus B. So you just add them together, you get that other one. Another way to think about it, and what's actually happening, right, is this vector is going to the right direction. U is going this direction. So together, whoever's more powerful will end up influencing which direction it's going. So both of these influence the new vector. See that? So they're kind of pulling each other, which becomes important in physics, right? So if you have two forces pushing in different directions, then you'll know where the object's going, right? That would be the U plus V. So by now, we're just doing it in general. That's what math is about. But if these vectors were forces acting on an object, and depending on the total, we'll know if that object is static or dynamic, meaning is it being pushed into one spot? Like for example, all the forces acting on this building, that would be a static force because the building is not moving or being smashed, right? So something that would be moving would be like, let's say you're driving in your car, you have forces pushing you forward, you got the friction slowing you down. Like as soon as you let go of the gas, right, it starts to slow down. You got gravity pushing you down. You got the force of the car on the asphalt pushing you upward, because there needs to be a balancing force, right? For every equal force, that's be an opposite one. So if there wasn't an opposing force to gravity, then you would fall to the ground. So there's got to be a force push keeping you up, right? Keeping you from caving into the ground. That's called the normal force. So you got equal force from gravity to called the normal force. So those are the two opposing forces. Now, if gravity overpowers it, then that's when you fall through the floor, right? Gravity won. The force acting on your feet pushing you up was not strong enough, or the surface itself fell apart, right? Those are all the ideas you'll see later. Now, again, these are general. So there's a total force. If this was some object, it'd be moving in that direction, this way, right? Does that make sense? Of course, you can also subtract. So U minus V, to check it out, you got to first draw the negative V, because V is over here, right? So if I were to draw it, let's see if we can get this correctly. Right. u minus v is over here. So that you draw your parallelogram around that. That should be from tip to tip here. So the one that I care about would be over here. Does that make sense? Let's see if we got it. Yeah. That's basically what they're doing.
Telling us the big C over and over again?
That's funny. If that's what you got from it, then I'm concerned. Let's see here. Anyway, so those are the conceptual questions. Over here, we're actually going to add the values together, but you should know conceptually what it's going to look like, right? If I add these together, we know that if I were to graph them, that hypotenuse in the middle that connects those tips will be the 5, 6. Okay, there's B this time. So if you graph it first, you can kind of see it pretty easily. If you don't, you'd have to add the components. So the A or the I plus I and the J plus J. You get this guy, 3 plus 2. Well, let's go ahead and do 18 on paper. So we did a bunch that I didn't write down, so but it's been recorded. Check it out later if you need to. So they want us to find u plus v, u minus v, 3u minus 5v. So notice here they're scaling them, right? And then subtracting. The u that they gave us was this guy. Three comma 2. Which is the same as 3i plus 2j. 2i plus 4j. So you don't forget that it's the same nonsense, just different notation. Okay. So part A, u plus v. If we leave it in the ij components, it's a little easier to see. That's a j, not 25. So that'll be 3i plus 2j plus 2i plus 4j. So just add the i's together and the j's together. 3 plus 2, 2 plus 4. So there's the new vector, which can be written this way if you want, or leave it. Who cares? B I'm gonna put the ones that we're doing, or each vector in parentheses, even though they don't really do anything. At least not in this example. Just so you know, this was the u and the v. So this is 3i plus 2j minus 2i plus 4j. So 3i plus 2j. So just distribute the minus, you're subtracting the entire vector, so put minus on both. So that'd be minus 4j. So 3 minus 2 is a single I. 2 minus 4, negative 2j. Any questions on A or B? Guys, okay so far? Okay. Let's do the scalar. 3u minus 5v. So scale them first and then just subtract them. Nothing crazy. So 3 times that first one, 3i plus 2j minus 5 times 2i plus 4j. So 3 times 3, 3 times 2, minus 10i minus 20j. So just distribute. So now this vector has been scaled by 3. This has been scaled by 5 in the negative direction. So if you were to graph it, it'd be 5 times longer, but opposite direction. This would be three times the length. When you combine them together, then you get negative I minus 14j. Any questions on that? Anyway, pretty easy, right? Okay. So we've learned how to combine two vectors, find the direction, or find the magnitude. Given 2 points, how to find the vector itself. Now we need, let's see, direction. Because we want to know what direction that vector is going. Yeah, let's do that. Guys, cool on this page.
Is that gonna be determined by the coordinates? Like that last one would have been like in the third quadrant, going like,
Yeah, technically that would be in quadrant 3.
so would that be what we're doing though, determining the direction like exactly, or?
Yeah, it'll be an angle in that quadrant. But those angles can be represented by different positive or negative. Okay. So when you're applying this stuff, finding the direction is pretty important. Find a unit vector. Actually, yeah, let's do unit vector first and then direction. Find the unit vector in the direction of V verify that vector V is equal to 1. So a unit vector, basically it's a representation of the original vector, but it's the length is 1. So you basically, you shrink it down on purpose. We do that a lot in application just so it's easier to do calculations. So like if we know where it's going, shrink it down and then create a unit vector. Now, in order to do so, to find a unit vector of V, divide V by its magnitude. That's all you got to do. So we'll call the unit vector U. Yeah, so that would be equal to the vector V over the magnitude of V. So in this case, that would be 3, -4 over the square root of 3 squared plus -4 squared. Okay. -3, -4. Oh, actually, it's positive. Nine plus 16, what is that? 25? And just divide each term. So the 5, the one is basically a 1/5 scalar. So dividing by its magnitude will then shrink it down to a vector of length 1, but it's still going the same direction as this one. Okay. That makes sense? No, so that's how you find unit vector. Just divide by the magnitude. That's it. Nothing special. On this one, we'll find the magnitude. and direction. Of the vector v. This will be problem 26. So magnitude, pretty easy, right? Just square each one and square root the whole thing. 4 plus -4 gives me a 32. 16 plus 16. Simplify this guy, that's technically 16 times 2, which is 4 root 2. So there's the magnitude. Now to find the direction, what you do is remember that the fact that tangent theta is equal to y over x, which implies that theta is equal to tangent inverse of y over x. So the angle will simply be tangent inverse of -4 over 4. So just take this as your like y, I guess. Y over the x. Okay. So that's going to be -45. And if you were to graph this, you would technically see it, right? And if you add 360, right, you'd have the positive version. Anyway, they're both the same. So there is 4, -4. See how it's right in the middle, right? So it should be at the -45. So -45 is down here, right? Over here. 315 is basically going from here all the way around to that spot. So same thing. These are the direction angles, positive and negative. I believe the homework wants the positive. I think. Let's check. So here's the magnitude. You said it was problem what? 20 something? 6. Yeah. See, they want the positive. Any questions on finding the angle? All right, last thing. So something that you're going to see a lot in engineering and physics is decomposing a vector into components of magnitude and direction. So notice right here on this question, they gave us the magnitude and they gave us an angle. So find the vector that's this long and goes in this direction. So we're going to need a formula. We'll do it on example 6. You guys cool on this page here? There's no rush. Good. Okay. Decomposing a vector into components of magnitude and direction. V is equal to AI plus BJ so that is equal to the magnitude of V times cosine of the angle alpha plus sine of the angle. How should I phrase that? No, hold on. It's cosine alpha. I is outside. Sorry. J is outside the sign. Yeah. So that problem, I think it was 27, right? Write vector V in the form AI plus BJ, given its magnitude. And direction. So alpha in that case is the direction. It's the ugliest alpha I've ever written, but there it is. Problem 27. So vector V is equal to the magnitude of vector V, sorry, is 2 root 5. Theta is 45 degrees. So V will equal the magnitude times cosine of that angle. So this would be the I and J components right there. So that would be 2 root 5 times cosine 45 I plus sine 45 J. So 2 root 5 times square root 2 over 2 I plus square root 2 over 2J. So this is from the unit circle, right? Multiply that out. That will be, so root 5 times root 2 is root 10. So that'll be 2 root 10 over 2I plus 2 root 10 J over 2. So I just multiply this thing times that one, this thing times this one. Square roots multiply like that. These 2's will reduce. So the answer is root 10I plus root 10J, which is the same as this. So that's all they're going to talk about in the homework. That's everything, I believe. Any questions on finding the magnitude, the direction, find the vector given only direction and magnitude, finding a vector given 2 points, and find the unit vector. I think that's all the bases. So let's do some practice problems from 8.2 before you leave. Try solving number 5. And number 6. Okay, so for little a, plug in the 12 squared, c, 24, minus 2 times 12 times 24, out of space. I'm gonna have to move this. Darn it. Times cosine was it 30? Okay. So this should give you the angle on your calculator, which I believe they said was 14.87. So it'll round to 2 decimal places, 14.87. Okay, so A is 14.87. B was 12. C was 24. Okay, so at that point, use your formula to find the angles, because once you have all 3 sides, you can find any angle. So B is equal to cosine inverse of a squared plus c squared minus b squared over 2ac. So that'll be cosine inverse plug it all in. Well, you should get the angle. So A plus C minus B, 2AC, yeah. So that should give us an angle of, just to save some time here, 23.79. And the last one, you can just find by subtracting from 180. So minus the 30 minus the one we just found. That'll be the last angle. Once you have 2, you can always find the third like this. $126.21. Ready? And that's it. All the sides, all the angles. Any questions on the steps? Is that all right? All right, we will stop here. So we'll hit a 8.3, was it no? 8.4 and probably 8.5 next time. 80% sure I'll be remote that day. I'll message you on reminder.